Good morning, class. How was the weekend? Welcome to our today's session. And today's session we are going to proceed with what we had last time. Before we start, I would like to confirm that all of us are present. So if I call your name, you just respond by raising your hand. Nili Nyamagi?
Present.
We have Boke Phillips.
Present.
Joshua Rotich. We have Yeno. We have Kitur. And we have Daddy as in the Based on? Yes? 8th of April 2025. So, as I've said, that today we are going to proceed with what we had in our previous session. If you remember well, in our last session we discussed the types of matter. And what did we say matter is? What is matter? Somebody? Yes, too?
Matter is anything that occupies space.
Anything that occupies space. And then we studied the kinetic theory of matter, where we say that matter is made up of tiny particles, which are in continuous random motion. And we say that for solid, the particles are closely packed, and the forces which holds the particles of the solid together, they are so strong. Then we say that for the liquids, the intermolecular distances between the particles in liquid are a bit, those distances are a bit longer. And for the gases, we say those the intermolecular distances, those distances are much longer. All right. So today we are going to learn the gas laws. Gas laws. And our learning outcome number one, we are going to define Boyle's law. That is our first learning outcome. Our second learning outcome, as a learner, you should be able to demonstrate Boyle's law. So by the end of the session, you should be able to demonstrate the Boyle's law, right? Then our third learning outcome, you should be able to apply Boyle's law. Is that okay? So let us start by defining the Boyle's law. Before that, I want to believe that each one of you, at a particular point in life, you've ever participated in playing football. Okay? That football, for instance, at some point, that ball, kuna wakati inafika pumzi inaisha pale ndani, si ndio? And you need to inflate the same again, and you use a bicycle pump to increase the pressure inside the ball, si ndio? So what happens when you start putting air into the ball in relation to the volume? Yes?
Try.
Yes.
As we pump in air,
The volume increases. So the Boyle's law is a law that operates under two variables, the pressure and volume. Pressure and volume. So to state the Boyle's law, we say that the Boyle's law Boyle's law states that the pressure of a fixed mass of a gas is inversely proportional to its volume when temperature is kept constant. That it is stated that the pressure of a fixed mass of a gas is inversely proportional to its volume when temperature is kept constant. What do we mean by being inversely proportional? Inversely proportional means that when one entity is increasing, the other one is decreasing. Alright? When one entity is increasing, the other one is decreasing. But the temperature must be kept constant. Alright? So I want to demonstrate that law, and I want you to have this in groups of two. Alright? That one is called a syringe. That's a syringe. And we can demonstrate the Boyle's law using the syringe or the bicycle pump. But in this case, we are just going to use the syringe. And that syringe has two main parts. We have what we call the barrel, and we have the piston. Let me have one of them. So we have a piston, the moving part. This one is the piston. Then we have the barrel. The barrel needs to go in. So I want you to do this. To pull the piston outside the barrel, you pull it outside. Pull the piston outside the barrel. Alright? Then I want you to push the piston inside the barrel. Listen, you push the piston inside the barrel, then you close the nozzle with your finger. Right? Then you close the nozzle with your finger as you are pushing the piston inside. Then note the force you require to close the nozzle as the piston is moving inside the barrel. We are pushing the piston inside the barrel, close the nozzle with the finger, and note the amount of force you require to close the nozzle as the piston is moving inside the barrel. Suppose, what's happening? Eh? So as you are moving the piston inside the barrel, you require a lot of force to close the nozzle. Alright? So when the piston is moving inside the barrel, what you are doing, you are decreasing the volume inside the barrel. Right? Yes. But the pressure inside the barrel is increasing. Yes. Remember we say that the pressure in gases is as a result of collision of the gas particles with the walls of the container. Right? So when you are decreasing the volume inside the barrel, the pressure is increasing. That means that the gas particles inside the barrel are taking very short period of time or very short distance to collide with the walls of the container, and therefore you require a lot of force to close that.
I have a question.
Yes, ask.
Why am I not able to push this? You call it a piston.
Yes.
Until the end, like this. Can you see? Why am I not able to?
Yeah, the reason why you are not able to measure zero volume,
Yes.
because we say matter occupies space. Alright?
Yes.
And remember, inside the barrel we have gas, which is matter. And therefore you cannot be able to measure zero volume.
Zero volume.
Alright? Is that okay? So from there, I want us to derive the Boyle's law. Remember we have said, with the Boyle's law, volume is inversely proportional to pressure. This one we call it proportionality constant. So if we remove the proportionality constant, we shall have V is equals to a constant times 1 over P. Sawa? And this one can also be written as P is equals to K over P. Alright? When we multiply both sides with P, we shall have P phi is equals to a constant. Alright? What does this tell us? It means that if we have a gas at a particular pressure, at a particular volume, and then we change the volume and the pressure of that gas from P1 to P2, and then P1 to P2, it means, sorry, I want to repeat that. This means that if we have a gas of a given volume at a given pressure, and we change the volume of that gas to another volume, the pressure will also change to another different volume. That is, if we have P1, we change this P1 to P2. Also, the volume will also change. Therefore, we shall have P1 is equals to P2, and this one is the mathematical representation of the Boyle's law. Mathematical expression of Boyle's law. Any question from there? Yes.
You're saying like we have the gas at maybe pressure 1.
Yes.
Now we're changing the gas at pressure 2.
Yes.
And can the same scenario happen when we have two different gases we want to compare? Let's say we are comparing oxygen and nitrogen. Does the same equation apply with just one gas at different temperatures and
Yes.
different pressures and volumes?
Again?
I'm saying, see, there you told us P1, V1 is equals to K, up to the M or P. Now, whatever the question is it about gases at different pressure and volume or about different gases?
In this case, we are considering one gas. If I have oxygen gas, so this oxygen gas, assume it is 50 centimeters cube at a pressure of 1 atmosphere. Alright? Then I change the pressure. I increase the pressure to 10 atmosphere. Automatically, the volume will also change. So,
Yes.
that is why I'm saying if we change pressure from P1 to P2, also the volume P1 will also change to P2. So, it's not about different gases. Yes. Up there. Are we okay? So the next thing, I want us to do a graphical representation of Boyle's law. If we have a data of pressure and volume, and we draw a graph of pressure against volume, this is centimeters cube, this can be in the atmosphere. Remember, we have said pressure, as we increase the pressure, volume decreases. When we increase the volume, pressure decreases. So if we have pressure, if we have a gas whose volume is too low, it means the pressure will be too high. Alright? If we increase the pressure, if we increase the volume, the pressure will decrease. And therefore, the result is a curve like this. And that is the graphical representation of the Boyle's law. From there, let's have a recap of what we have learned. So Somebody to tell us what they have learned. Guardians, what have you learned today?
I've learned about the cholesterol.
Yes.
Learned the how you drive the cholesterol.
Okay.
P1 is equals to P2, P2.
Correct. Nyamari, what have you learned?
The definition of voice.
Definition of voice. Can you define it?
Said that it
Somebody to help her? Yes?
Okay, voice loss data. Pressure is inversely proportional to volume. Constant temperature.
Correct. Now, for your assignment, this is your assignment. Go and do this one. Calculate the volume of a gas. Calculate the volume. Calculate the volume. Sorry. Calculate the pressure of a gas calculate the volume a gas will occupy when 50 centimeters cube of a gas at 10 atmosphere is compressed to a pressure of 12 atmosphere. That is your assignment. So when you come next, I should find you having done that assignment. So until next time, anybody with a question? Thank you.